Welcome friends. Today we will be learning about correlation and we will see how different types of correlation are computed. So let us start the presentation today. Here we have, before we understand correlation, we have to understand variables. You know, variables are those whose value varies. So here we are in correlation, we basically start with understanding the relationship between two variables. So we have two variables and we have values of those variables available to us in pairs. It means the same subject or same individual, for I have the values for x and the value of another variable y. And we are interested in learning the relationship between the variables x and y. So first to start with, we have data about two things, and then the first step towards understanding relationship between variables is through the help of a diagram called a scatter diagram. So here we have data on two variables. The first variable is that of x, that is we have age of the rider, let us call it x, and the average speed in which they drive their motorcycle, let us call this y. So we have the values on x and y, and based on these values what we want to do is to find the relationship or try to understand the type of relationship between age of the rider and speed of the average speed in which they drive their motorcycle. So this is the data set. So age is measured in years and speed of the motorcycle is measured in kilometer per hour. So this is a 16-year guy who actually drives on with an average speed of 62 kilometer per hour. So this is the same guy and the same speed. This is another person, 22 years age, and this is the corresponding average speed in which he or she is driving. So this is what we have, what we mean by data available in pairs. Now once we draw the scatter diagram, we arrange the data in this way, and then we actually write or draw the x-axis, and then we plot the values of the x-axis. So here we have to arrange the x-axis in such a way that the minimum value, as you can see, the minimum value is 16 and the maximum value I think is 53. So both the values 16 and 53 are included. So we start at some point smaller than 16, that is 10 here, as you can see, and we go up to some value above 53, and that is 60. So we have this, and then we have the value of y-axis. Along the y-axis we have the speed of the motorcycle, and so here also you are to arrange your y-axis in such a way that the minimum value and the maximum value can be accommodated so far as speed is concerned. So these you draw the axis, and then let us go first is you see 16 and 62. So we plot here, and that from this we plot a point, find out that y and 16 and 62 along y-axis we find out, and then we draw hypothetical straight lines perpendicular to x-axis and y-axis, so that we find the meeting point of the two wherever they cross, and that is the point called as 1662. Similarly, we go to the next value, and as you can see, the next value is 22 and 60. So we find out the value 22 along x-axis, and we find out the value 60 along y-axis, and draw perpendiculars from those 2 points, and the point in which they intersect or meet, that is the where we plot the point, next point, that is 22 and 60. In this way we proceed and we get this type of diagram, and this diagram is called as the scatter diagram. So these scatter diagrams helps us to understand the relationship between variables in a sense that here we have age and along the y-axis we have speed. So we understand that as you can see, as age increases, as age moves in this direction, there is a tendency of speed coming down. So this is indicating that there is a negative relationship. So as age increases, speed is coming down. That means with increased age, people actually tend to drive at a lesser speed. So that is what we mean by a scatter diagram. Gives a rough idea about the type of relationship that might exist between the variables. Now if you want to draw this in Excel, because always manually drawing is these days not a wise decision, because you have so many options, so many most things are done in computers, so many softwares are available these days. One handy package is Microsoft Excel, which is not a statistical package but can be gainfully applied for doing many statistical computations as well. This is basically a spreadsheet. Anyway, so we write the values, type in the values, as you can see here I have typed in the values, and then we go to insert menu, and insert menu there is a sub menu which is called a scatter under charts. So there you have the option and you may select the first option and then just click on after selecting the data, then you will get a diagram like this coming up where it is showing the values of all the points. So this is how we draw the scatter diagram in Excel. You may please try this at home. Okay, so this is how we draw a scatter diagram in Microsoft Excel. So as we understand the scatter diagram, before that we let us have a hint about relationship. What are the different types of relationship? Basically, we are looking at either a positive relation, a negative relation, or say no relation. Now, positive relation means as the value of x increases, the y is also showing an increase. So this is the relationship. This is another relationship. Negative relationship means as x increases, the value of y is showing a decrease. So this is an indicator of a negative relationship, or a straight line like this. And then we have something no relation. No relation means where actually there is no trend clear, like whether increasing or decreasing, nothing is clear. Then we have a trend of no relation. As you can see, this is an example of no relation. And then we have sometimes some graphs like these, that if you look at this scatter diagram, you understand that till this point of x-axis, there is a tendency of the values falling down, and then after that it is showing an increase. So this is basically a relationship which is not actually they are independent. You cannot tell that there is no relation, but there are conditional relationships, that till a particular value of x it's in a decreasing trend, and after a particular value of x we can see an increasing trend. So this type of things are clear in a scattered diagram. So but then we want to quantify the relationship. We want to find out that how strong is the relationship, whatever it is, either positive or negative. So for this we come up with a term called as correlation coefficient, and this correlation actually measures the extent of relationship between variables. It was developed by a British mathematician or biometrician, Karl Pearson, and the notation for the correlation coefficient is generally small letter r and within bracket xy or r suffix xy. So this is the form. This is about correlation coefficient. It was developed by Karl Pearson, and this is Karl Pearson in his older days. He had, when in his younger days, he looked like this. So, but then let us look at the formula of this. The formula of the correlation coefficient. There are different formula available for the Karl Pearson's formula for correlation coefficient. Actually, the same formula, but presented in different ways, and this is the most common formula used for computational purposes because this is easier to understand. So we'll see what this is summation xy, this is the average of x, that is x bar, this is the average of y, that is y bar, and this is the number of pairs. That means if you have 10 pairs, and then this is summation x square, this is n x bar square, n and n y bar square, and this is summation y square. So in order to compute correlation coefficient, we need to know summation xy, or rather we need to compute summation xy. We need to compute x bar, summation xy. We need to compute summation x, because summation x will give us x bar. Then we need to compute summation y. Summation y will give me y bar, and then we have summation xy. Summation xy is already there. Summation x square and summation y square. So these few columns I need to compute, and then I can compute this correlation coefficient, or Rxy. Now this value of Rxy lies between -1 and +1. So if it is towards +1, it indicates a positive relationship between the variables. If it is towards -1, it indicates a negative relationship between the variables, and otherwise it is, if it is closer to 0, it means no relation. So here we have a table which will help you to understand or interpret correlation coefficient. If you look at this, if the value is +1 correlation coefficient, that means both the variables move in the same direction, either both of them increase or both of them decrease in the same proportion. If it is -1, it means that both the variables move in the opposite direction. That means if one increases, another will decrease and in the same proportion, and this is called as perfect positive correlation, and this is called as perfect negative correlation. Now we have a situation when the correlation is exactly 0. It means that the variables are uncorrelated. Uncorrelated means there is no existence of any type of relationship, linear relationship, no linear relation between the variables. Well, other types of relation like quadratic, cubic, etc. might be there. So you may not tell that they are independent, rather you should tell that they are uncorrelated. Uncorrelated means no linear relationship between the variables. Okay. Well, now it is 0 from either side. That means small values just greater than 0 in the positive side or just negative values. So these are examples of very little correlation between the variables. If it is near +1, then the variables are highly dependent on each other. And if it is near -1, then the variables are highly dependent on each other, but in the negative direction. That is, if one increases, another is supposed to decrease. If it is near -1, if it is near +1, means one increases, then other is also supposed to increase, and vice versa. So this is about the interpretation of the correlation coefficient. Now let us see how we can do this computation. Now computationally, suppose we take an example that these are data of 12 people. These are their ages, as you can see, and this is the number of minutes per day when they are engaged in watching a particular app in mobile, maybe a OTT. Okay, app engagement. So I have data about the ages and I have data about their app engagement, and I want to find out the relationship between the two, and I want to use Excel for that purpose. So if you are doing this Excel, you just type in the data as we have seen earlier, and then we write equal to Karl. So this is the function. This is the function of correlation coefficient in Excel. And then within bracket we first give the range of the first data set, that is this one, and then comma, and then we give the range of the second data set, this, and then we press enter, then we find the value of correlation coefficient. As you can see here, the correlation is negative and the value is minus 0.7281. That means it is highly negative, high negative correlation. That means there is a relationship between this, but the relation is negative, and if one increases, another is expected to decrease. So this is how we interpret the values of correlation coefficient. But if we are asked to do the manual computation and reach to correlation, let us have this data now, a different data set. So you can see heights I have for 15 people. As you can see, there are, if you count, there are 15 people. That means n is 15. And here the weights of the corresponding individuals. And I want to compute the correlation coefficient between them manually, not with the help of Excel. And so let us see how to compute this. So this is the data that we have. So I have typed in the values of, or written the values of x and y. What we require additionally is x bar and y bar. For that we require summation xi. That means summation of the values of this column, that I have written summation x as this, and then we have written the values of the sum of y column, and that has come to this. Next we make a column, and that column is this one, that is, we have the column x square. So x square column, so just we square it up, that means 56 into 56, this is equal to this. Next value is 78 into 78, and that is equal to this. Like this we go on, and lastly we find 59 into 59. So we have this. So we take a sum of all the values of this column, and we get this 59,140. Similarly, we have the value of y. It means y I have 149 into 149. So that is equal to this 22201. So this way I calculate the value of y square for the values of all the column. And then we have summation y square. So we have summation x, summation y, summation x square, summation y square. So these values. Lastly, we require another column, and that is xy. That means 56 into 149. That is the first value. 56 into 149. This is equal to this value. 78 into 164. And this is equal to this value. So like this I get all the values, and ultimately we have the summation xy, this 151801. So these are the values. So I have summation x, summation y, summation x square, summation y square, and summation xy. So these are the 5 columns that we require to compute manually when we want to compute the correlation coefficient manually. And then lastly comes the formula. So always when you do some computation, please write the formula so that there is no error. So we have first is summation xy. So this is the value of summation xy. Then we have n. So n is 15. Then we have x bar. You see here x bar. So 926 by 15, that is my x bar, and that comes out to be 61.7. Then we require y bar, which is summation y by n is 15. So 2442 by 15, that is 162 by 8. So this is y bar. And similarly, summation x square we get it from here, summation y square we get it from here. X bar and y bar already we have computed, n equal to 15. So we replace these values. Remember that this is x bar square and this is y bar square. So when we replace all these values and do the computation, then we find that the correlation comes out to be this. That means there is a positive relationship between height and weight, and as height increases, weight also shows an increase. May not be in the same proportion, but there is a tendency of showing an increase. So that is how we calculate the Karl-Pearson correlation coefficient. Whenever you compute correlation coefficient, please don't forget to interpret the result. For example, here we got the correlation, and then you see in the previous we have an interpretation like this. So correlation is this. This is plus. Don't forget to write the plus 0.6551. Interpretation. The correlation is positive and high. It is height and weight are positively related. This indicates that as height of an individual increases, the weight shall also increase, and vice versa. So here comes the interpretation. So this way you need to interpret the result. If it is negative, you will interpret in the reverse way, that the relation is negative. So if one increases, another is expected to decrease. Next, let us see about another type of correlation, which is called as rank correlation. It is measured by rank correlation coefficient, and it was developed by Spearman. Like a Karl-Pearson correlation coefficient also, this lies between -1 and +1. And interpretation is actually done in the same way as that of the Karl-Pearson correlation coefficient. But this is basically used to find the relationship between two variables which are in the form of attributes, not necessarily those things which are measurable. Like in Karl-Pearson correlation coefficient, we deal with variables which are measurable in nature, like height, weight, distance, salary, income, blood pressure, blood sugar, etc., which are measurable. But many things which are in the form of attributes, which are generally given some score, marks or ranks. So those variables, when we want to find a relationship between attributes, then this type of correlation coefficient, that is the Spearman's rank correlation coefficient, is generally measured. Now let us look at this, that suppose these are the ranks of or scores of 10 individuals in beauty and intelligence. So beauty and intelligence both are abstract things which are actually attributes, but some scoring system has been developed and it has been scored. Such scores might not be universally accepted, so these are generally computed, or the relationship between these two variables, that is beauty and intelligence, x and y, are measured through ranks. So first we will convert these scores into ranks. So we have these as the ranks of x. That means the maximum value in x will be ranked 1, the next maximum will be ranked 2. This way it will go on, and then we have completed the ranking of x, so we get the ranks. So 10 values, you can see that we have a rank 1 to rank 10, and once this is done, then we actually rank the score of y. Then this is once again we do it afresh. So 81 is the highest value amongst y, so this is ranked 1. Then 77 is the next highest, this is rank 2. So we have the values of ranks of y in this way. And then after doing this next step, simple computation is there. We just find the difference of the ranks, and then we find the square of the difference. So 7 minus 6, that is 1, and then square of 1 is 1. Then 6 minus 7 is minus 1, then square of that is 1. So one column we find the difference, and the next column we find the square of the differences. So this is the square of the differences. When we compute the square of the differences, we add them up, and this is called a summation di square. And now we come back to the formula. Formula is simple. 1 minus 6 into summation di square, that means 12, and divided by n into n square minus 1. In this case, n is 10, number of pairs is 10, so 10 into 10 minus 1. So this is what we have, and ultimately we get the value 0.98. As I tell that this is always the right plus or minus, obviously this is plus 0.98, and interpretation is in the same fashion as that of Karl-Pearson correlation coefficient. So you will conclude that there is, based on our computation, the rank correlation coefficient is highly positive, and there is a positive relationship between intelligence and beauty. That is how we compute and conclude or interpret our rank correlation coefficient. Thank you for watching this video.